So last week we started understand of semiconductor devices. We learned about what semiconductors are and what their advantages are. In the exam that was given, everybody got the right answers. The advantages are definitely they're smaller, they're more reliable, they are way less. So basically, those are miniaturization type stuff, okay? And it's because of that that we were able to carry uh, devices in our pocket that run off of batteries, okay? So the miniaturization is very important, but it's not the only advantage because the big advantage of our new technology is timing. Uh, we run equipment now that it runs in gigahertz speeds. What that means is a gigahertz, for example, is a speed where the we have little jumps in time that are 1 billionth of a second. 1 billionth of a second. Okay, where our minds operate at tenths of a second. So they can perform things much faster than we can do it by through just simply thinking it out. Okay, so we use these devices, computers essentially, to solve problems that are enormous, and they'll do it in record time, uh, a lot faster than we could do them, decades ago. Okay, to give you an example, I had when I was working in the aerospace, we created a process by which we could measure uh, the amount of fuel in a fuel tank using a model that counts in the tens of thousands of parts. Okay, uh, so the way to do that is to solve tens of thousands of simultaneous equations in tens of thousands of uh, variables. All right. And to do that by hand would take you days and years, almost years, and so forth. Well, by using a computer that I used a computer to solve some equations. To solve that, the computer came up with the answer in 15 seconds. 15 seconds. Imagine that. Okay. Uh, so timing is of great importance. This is a great advantage that we have with our new technology that we didn't have earlier on. Okay. But not all devices are that fast. Okay. The technology has grown to make the devices fast. Initially, uh, we used very slow devices. Very first home computers ran at kilohertz speed, not gigahertz. Today they're at gigahertz speeds. You can get your computer to work at gigahertz speed. So that's 1 nanosecond versus a millisecond. Okay, big difference, big difference. And we do tenths of a second. All right, that's a big, big difference. And it's because we can do that now that solid state devices have an advantage over the old technology. So where we left off last week was with the bipolar junction transistor. Okay, we basically two PN junctions back to back. It's driven by currents. Okay, to give us amplification. And that's what their major use for bipolar junction transistors is the amplification. Okay, they're great amplifiers. All right. Today, we're going to start learning about another kind of transistor called a field effect transistor. The field effect transistor operates not by current driven, but by voltage driven. Okay, voltage driven, and it then gives us variable currents. Now we can get amplification with these devices, FETs, but it's not as great. Okay, and it's a little bit slower than the bipolar junction transistor. Nevertheless, they are much easier to build. They're a lot less costly to build, and so there's a plus on the FET side. The other advantage is because they're so much easier to make, that most of our integrated circuits use the FET technology. Okay, and so, but those devices then are used in circuits where we do a lot of signal conditioning. What does signal conditioning mean? Well, circuits that we use on submarines, on aircrafts, and a lot of vehicles and other motor-driven equipment use systems that use sensors, okay, that operate at different voltages or current. So the system itself has to be set up to pick up the power, okay, and the power is our normal everyday power that we use, whether it comes from a battery or from an AC power. And then we have to convert that to different voltages and different currents according to our sensors. What do our sensors need? Okay, so we do that by signal conditioning. We take the power signal and we condition it to operate with the sensor. And the sensor itself puts out an output that we have to measure. So we have to do signal conditioning with the output from those sensors. So every system that we have then operates with these sensors, and we need signal conditioning in a lot of these black boxes that we use to operate at different systems, whether it be in a submarine or an aircraft or even a car, etc., etc. That's what we call signal conditioning. Okay, but today we'll start with the field effect transistor, and if you have any questions, please let me know what you're not getting, or if you're having difficulty, let me know. I will write something special to help you understand it. Okay, so let's get going.